All right, welcome to Math. Mr. Jorgens here, section 7.7 on factoring special products. We're going to be talking about something called the difference of two squares today. So stay tuned, a few questions for you. This one will be a little quicker than some of the past ones we've had, but definitely stay tuned for learning. All right, so where we're going to start is with the multiplying problem. So we're going to look at the multiplying problem a plus b times a minus b. And the way I would do that is with the box. And a plus b is my first factor, so I'll put that on the rows. My second one, a minus b, I'll put on the columns. Then I'm going to go ahead and multiply in each box. Top left box would be a times a, so a squared. Top right is a times negative b, so minus ab. Bottom left is plus ab. And bottom right is minus b squared. So when we look at this, when we go to add up the boxes, I have a squared. That's my first term. I have a plus ab. As my second term, I have a minus ab as my third term. And I have a minus b squared as my last term. What you're going to notice is that plus ab and minus ab are going to add to 0 or cancel. And I'm just left with a squared minus b squared. So in general, we know that this equivalence is true. A plus b times a minus b is equal to a squared minus b squared. Now, what that leads us to is our rule, which is called the difference of two squares. And difference means subtraction. So subtraction of two squares. So if you notice, this is the difference, meaning subtraction, and you have 1, 2 squares, right? A and b are the two squares. So the rule is if I have a difference of two squares, I can rewrite it in factored form as a plus b times a minus b. Because remember, right now in this chapter, we're factoring. So I'm trying to take some polynomial and turn it into a factored form. So that box kind of sets us up. But this is our rule that we're going to be using today. A squared minus b squared equals a plus b times a minus b. So what we're going to be looking at today is we're going to be looking at problems that don't have a middle term. Like a lot of the problems we've been doing the past days would have been something like x squared plus 6x plus 9, right? But today is all going to be stuff without that middle term there. All right, and the way we're going to be able to think of it is I'm going to want to set it up as something that looks like a squared minus b squared. Because if I set it up like that, I can rewrite it as a plus b times a minus b. And so I want to rewrite this as an a squared minus b squared. And what I'm going to have to do is I'm going to have to rewrite my second term as a second square, right? Because I already have my first one written as x squared. But I need to rewrite my second one as a second square. So it turns out that 9 is equal to 3 times 3, so 3 squared. So I can rewrite my 9 as 3 to the power of 2, because 3 times 3 is 9. Once I kind of set that up, I'll know my a is x and my b is 3. So I can rewrite it as a plus b, a minus b. So x plus 3, x minus 3. And these problems go pretty quick because we're just using the rule to rewrite. Now if I want to kind of prove this by checking my work, x plus 3 times x minus 3, I'd have x squared, I'd have plus 3x, minus 3x, and minus 9. Of course, these two boxes are going to add to 0 or cancel, and I'm just left with x squared minus 9, which is what I had originally. All right, so we have to kind of know how to rewrite the b term as a b squared, and then just use our formula to write out that factored form. All right, so we're going to try another one here, 16x squared minus 36. And for this one, I don't just have an x squared at first, right? So I'm going to have to rewrite both of these parts as something squared. So I'm going to want to write it as something squared minus something squared. That's always what I want to do. And then once I have an a squared minus b squared, I can rewrite it as a plus b times a minus b. So let's start with 16, x squared. 16 is 4 times 4, and x squared is x times x. So 4x times 4x would make 16x squared. So I can rewrite that as 4x squared. So I don't just have an x squared, I kind of have to rewrite both the a and the b parts. Second part is 36. So 36, what number squared would make 36? Enter your answer when you're ready. Yeah, it'd be 6, right? So we have 6 squared, so it'd be 4x squared minus 6 squared. So that's going to mean that my a here is 4x and my b is 6. So I can rewrite it then as 4x plus 6 times 4x minus 6. And that would be my difference of two squares. All right, we're going to try another one. 25x squared minus 1. So 25x squared, I'm going to have to write that as something squared. And then the 1, I'm going to have to write that as something squared. So let's start out with 25x squared. I need to write that as something times something, again, where we could just write it as that thing squared. Again, there's probably going to be an x on there. But tell me what quantity squared would make 25x squared to put on this red line here. So go ahead and figure that out and enter your answer when you're ready. Yeah, it'd be 5x, right? Because 5x times 5x is going to make 25x squared, so 5x squared. And then 1 is just 1 times 1, so I can write 1 squared is the same as 1. So I kind of know now that my a is going to be 5x and my b is 1. So I have a squared minus b squared here, and I'm going to rewrite it as a plus b times a minus b. So I can write it as 5x plus 1 times 5x minus 1. As my difference of two squares here. All right, here's one for you to try. X squared minus 49. Go ahead and factor that using the difference of two squares and enter your answer when you're ready. All right, so we should have been able to write this as x squared minus 7 squared as an a squared minus b squared. And then when I go ahead and rewrite it as a plus b times a minus b, I'd have x plus 7 times x minus 7. So that would be our factored form after we factor using a difference of two squares. All right, last one for you to try, example 5. We're going to do 4x squared. So again, I'm going to have to factor out this first part as well. So 4x squared minus 100. So go ahead and factor that using the difference of two squares and enter your answer when you're ready. All right, so on this one, you can see that the a would be 2x, because 2x times 2x would make 4x squared. The b would be 10, because 10 squared is 100. So I can then rewrite it as a plus b times a minus b, so 2x plus 10 times 2x minus 10, which would be our factored form using the difference of two squares. So difference of two squares is a super helpful rule to help us factor things quicker when there's no middle term. So if we have something in this format, a squared minus b squared, that's the only time we can use the difference of two squares, but it is definitely a helpful rule when it is in that form. Thanks for staying tuned for learning today. You guys should be ready to start that big ideas math practice, and I'll see you guys next time.